All right, this is creativity time. I'm asking you to find a piecewise function that has all these properties. Well, let's start out with some easy ones. We know at 1 it has to be 2, and at negative 2 it has to be 10. So what I'm going to do here, check this out. Now your function could be completely different from my function. Okay, there's a million different infinitely many different functions that have these properties. Okay, but watch how I do this. I know at 1 I want it to be 2, and at negative 2 I want it to be 10. Well, I'm going to define that at x equals negative 2, that this function equals 10. There you go. That's how easy that was. At negative 2 it has to equal 10. Well, when x is negative 2, this function equals 10. No problem. I'm also going to define that at 1, at x equals 1, this function has to be 2. Well, I just took care of E and B. Okay, now there's going to be other pieces in here. Like, I don't know what's going on here and here and here and here. Right? These are all just question marks. I got to find out what they are based on these other rules. So let's take a look at the other rules. Let's see if we can find some other pieces here. I need, as x goes to negative 2, the function has to approach 3. So the limit has to be 3 as x approaches negative 2. Well, at negative 2, my function equals 10. I've already got that set up. But what that means is, as x goes to negative 2, let's think about this. As x goes to negative 2, I want this function to be headed to 3. That's what that says. Okay? Doesn't matter what happens at negative 2. I need the function to be approaching 3 from both sides. And at negative 2, it tells you it equals 10. Well, that's way up here somewhere. There's 10. That's not really to scale, but it's a point way up here. So all I got to do is make sure that on both sides of negative 2, my function is approaching 3. Well, here's how I'm going to do that. When x is less than negative 2, I'm just going to make a function that stops at 3 when x is negative 2. Ready for this? X plus, guess what? 5. There you go. If this function is x plus 5, then as x approaches negative 2, this function approaches 3. That's what this is. Boom, right there. When x is greater than negative 2, okay, now I'm going to need another number here. I got to tell it to stop somewhere. But when x is greater than negative 2, I also need it to approach 3. Now I can make any function I want. I'm going to pick x squared, okay? At negative 2, x squared is 4, so I need to subtract 1 off of that. There you go. So now what I've just done, let's check this out again. F of negative 2, that's 10. As x approaches negative 2 from both sides, it equals 3. From the left, negative 2 plus 5 is 3. And from the right, negative 2 squared is 4 minus 1 is 3. Great. Okay, so now this is taken care of as well. Also, we need the limit as x goes to 1 from below to be 4. All right, so I could try and put a 1 here and then try and make this thing approach 4 at 1. But that might change what it approaches at negative 2. So since I don't feel like having to deal with two conditions for this one function, what I'm going to do is say that this thing stops at 0. Okay? Let's just say between negative 2 and 0 it equals this, because it doesn't say what happens at 0 on my list of rules here. So I'm just going to stop at 0. And I'm going to move this thing. No, not the whole thing. Ugh. I'm going to get rid of this for a second. I'm going to slide him down because I need more room. Okay? So the limit as x goes to 1, well, let's pick a new function here. From below, well, that's going to be this function. Okay, as x goes to 1 from below, I need it to equal 4. Well, here's this right here. X is going to 1 from below. That means x is less than 1. That's right here. And I can pick any function I want, but it has to equal 4. Well, I'm just going to make it x plus 3. As x approaches 1, this thing approaches 4. This one's done. But I have to make sure that the limit as x goes to 1 of f of x does not exist. Okay, well, that's no problem. I am not a big fan of how this thing selects my stuff. So it equals, what, 2 at 1. So at 1, it equals 2. Cool. I need the limit as x goes to 1 of f of x to not exist. So all that means is on the other side of 1, I just need to make sure that it's not approaching 4. Okay? So I can really have any function I want over here, just as long as it's not approaching 4. So I'm going to hold off for a second here, and let me see here. Oh, I also need the limit as x goes to 4 of f of x to be infinity. So I am going to choose this to be x minus 4, 1 over x minus 4 squared. And the reason I am choosing that is because now when x is going to 4, as x goes to 4, so let's just say happens when x is greater than 1, okay? Well, now when x is greater, we're going to 4. That means I'm entirely on this interval, which means I'm looking at this function only. If x is going to 4, I need it to be infinity. Well, that really means there's a vertical asymptote at 4 where both sides are going up. That's what that means. So I just made it 1 over x minus 4 squared, because now as x goes to 4 from the left, the denominator is getting super small, which causes the asymptote, and it's going to go positive because we're squaring the bottom. So we have a positive 1 over a positive small number goes to infinity. As it goes to 4 from the right-hand side, this denominator is going to be a positive number squared, but a very tiny number, and 1 divided by a very tiny positive number just makes this thing shoot up to this side as well. And I just took care of this. But in doing so, I also took care of d, because now the limit as x goes to 1 does not exist, because from the left-hand side, we're on this part, and that's going to 4. That was c. That's working out. But from the right-hand side, as I approach 1, now we're on this function. This thing's headed towards 1 over negative 3 squared, which is 1/9. So basically, what I did with this thing is I made it so that the limit as x goes to 1 from above, which is on this function here, is 1/9. And that does not equal 4, which is what the limit from the left-hand side equals, which means it's going to different places from the left and the right. So there you go. That's just one example. That took a lot of work. There's a lot of thinking going on there. It probably helps to draw a picture first. I didn't do that. Maybe I should have. But that's okay. You can make up another function if you want and check it out. You can create the same intervals. It doesn't matter, but that's how you would go about that process.